Hello and welcome everyone. Let's continue solving the Schoenprozad list by tackling this problem, average of levels in a binary tree. So we are given the roots of a binary tree here and we want to return the average value of the nodes on each level. So we can see that we have the roots, we have the second level and we have the third level. And for every level we want to return the average value of the nodes in each level. So at the root, we can see that the average is 3. On this second level, we would have 20 plus 9 divided by 2, which we can clearly see from the output is 14.5. And if we do the same for the third level, we can say that our result will be 11. Right? So this is the problem. Now, how do we go about solving this? Alright, so we are given a basic tree problem. Let me try to replicate something similar. 9, 20, 7 and 15. The brute force way, or the most intuitive way of solving this problem, is to kind of like run a traversal, right, where we visit every node in the tree and try to find the average at every level. Now there are two ways of traversing a tree, and the first way is called breadth first search and the second way is called depth first search. Now breadth first search means that for every node here we are going to explore its children. For every node here we are going to explore its children, which is non-existent for this one, and for every node here we are going to explore its children. We are going breadth, step by step. Literally, that's what it means. But for depth first search, we are going to explore deeply. We're going to explore one node, one area deeply. Let us say that we start from this place. We're going to explore 20, then we'll go ahead and explore the children of 20, which is 7 and 15. Then we'll take one of the children of 20. Let's say we visited 7 first, and we will explore that, but we can say that we have nothing. So we go back up to the parent of the last node we visited. We visit the children 15. We can say there's nothing. When there's nothing else to visit, we go back up and visit the last child. That's basically what depth first means. Depth first means that we solve for depth first. We go down one part, we solve for one part down, then we solve for this next part or whatever it is next. But for breadth first, we're solving it in kind of like a scattered way, right? Not really scattered, but we are covering a whole lot of ground. We are going breadth, we're taking a lot, all of the children. Now from this analogy you can see that the best option to use to solve this problem is this breadth first search. Now if we're solving depth first search, we need to traverse down this entire tree, but we don't need to traverse down the entire tree in this case and then start to keep stock of what level we visited. We can use a breadth first search where we are visiting every level. A breadth first search is also called level order traversal because we are traversing the levels in order. And let me kind of like give us more room and make the tree a bit longer so that we can see what I mean better. All right. So a binary tree, I don't think I discussed this, but a binary tree means that every node has two children. You can have no more than two children, right? Let's say 9, let's say 10, let's say 11, and let's say 12. Now for a breadth first search traversal, recall that there are only two ways of traversing through a tree: breadth first and depth first search. Now for a depth first search, we are going to traverse every depth. If we go from 3 to 6, we go from 6 to 8, we go from 8 to whatever this number I meant to write. Since there is nothing else to explore here, then we go back to 8, explore this. If there is nothing else to explore here, we go back up, go back to 6, explore all of the children of 6, and that is how we do for depth first search. We are favoring depth, right? But for breadth first search, we are doing it in order. Level order traversal, we're traversing the first, everything on this first level, all of the children of the next level, all of the children node of the third level, and finally all of the children node of this last level. Now from our question, we want to find the average of every level. We want to find the average of every level, because this is the level. We have this tree, means we have 1 2 3 4, we have 4 levels. For every level we want to find the average. So the best way of solving this is to use the breadth first search, because we want to traverse each node, in order. So we want to use the breadth first order. We want to get the node, the average of every node on each level. So we want to use the breadth first search method to solve this problem. All right, lastly, let's give ourselves more room and see how we might approach this problem. So again, we have 3, we have 9, we have 20, we have 5, and we have 17. So how this is going to work is, in a breadth first, we use the data structure called queue. Queue is a data structure that is like kind of like a list, and it's a list of value that follows the principle of first in, first out. Just like a normal queue in a restaurant, a gas station, or wherever, first in, first out. So we're going to be using a queue data structure to solve this problem. And so we're going to initialize a queue in the code, but let us make this conceptual. So we have a queue data structure, and we are giving the roots, right? So we store our roots in our data structure, and then we check, do we have any other node on this level? No, we do not. So we're going to take the average of the number or the value in our queue data structure. We're going to get the average of that data and append it to our final results, because in the end we want the result of all of the averages at each level. So let's assume that this is our final result, and we have 3 here. Then we go again and we go to, but before we remove this from our queue data structure, remember that we are first in, first out, so we are popping the values off of our queue. Now before we pop this off, we are going to check for all of its children, and all of its children is 9 and 20, right? All of children is 9 and 20. So we check again, do we have any kids on this other level? No, we do not. So what do? We get the average of the numbers, the values on this list, and we add it to our final result, right? Then finally we get all of the children. Before we pop 9 off, we get all of the children of 9, but 9 has no kids, so there is nothing to add. We check all of the children of 20, and 20 has 5 and 11. 5 and 11, we get the average once we can see that there is nothing else to add, and we return this as the final answer. But before we return this, I want to show you that it is possible, right, that we have values for, let's say we have something like 2, and let's say we have something like 4 here. So right before we pop off the value of 9, we can check, does 9 have any children? And yes, it does. So we will append 2 and 4, right? And because 20 is still part of this level, we pop off 20, we check, does 20 have any other numbers? And yes, 20 does. So we'll check that, okay, it has 5 and it has 7, and then we can get the average of all of these numbers. This is just to show that there can be numerous the possibilities is endless. It does not have to be constrained within the tree that we are given. There can be, just know that all of the trees, right, all of the nodes must have 2 children, but this is an imbalanced tree. An imbalanced tree is where what we have currently, that this does not have children and this have children, but it can be a balanced tree and everything has children, right? So we have to also take note of that. And when we are writing code, you know that our code can also accommodate that our node each of our node can have children, and everything will still count as being on that same level, because if 9 had children, then basically there will be 4 children on this list. Now let's jump right into the code. Alright, so let's jump into the Python code quickly. First, we want to define our results variable. This is the variable that would output our result. And then we also want to define the data structure that I said we would use to store the values or the nodes at every level of traversal. So with Python has an inbuilt library called deck, and this deck is an inbuilt queue structure. Queue structure follows the first in first out principle, so we want to remove the first element in the list. So this deck is an inbuilt Python library that allows that. But first, we are going to add our first element in the tree, which is basically the root element. We're adding it to the queue, and while we have a queue, of course, while our queue is non-empty, we want to first define our total, right? For every level, we want to find the average, and we need the total of the average divided by the length. So I want to set the total to a default of 0. We also want to get the length, not okay, we don't need this is JavaScript syntax. For Python, we don't need that syntax, but for then we need to define the variable that gets the length, right? Because when we want to find an average, we're basically doing total divided by the length. So the total is initially set to 0, and the length of the queue is basically the length of the queue. And then we want to find the average for every level, right? So for the first level, we want to find the average for that particular level, that range. We only want to find the range for that particular level. That's why we're using a range, so it will not exceed that level, because at every range we believe that is all of the values at a particular queue. So the range of the length of the queue. And just to be clear, so for instance, presently we have if we have 3, I'm pointing at 3 here. If we have just 3, we want to find the average at the root. When we move to the next level, because we've added new elements, the children of our previous elements, we've added them to the queue, so we don't want to just have this endless loop. We have to set our range such that whatever value that was in the queue before we started finding the average is only that range that we're going to run our operation on, because that defines that level. All right, so once we've gotten the range, we want to get the next value in the iteration. So we want to pop off the first element or the first node in our tree. So we're going to pop left is going to pop off the first node in our tree, and then we want to add the value of that tree to our total, right? Recall that we want to sum up all of the values so we can find the average. And if this node has a left value, then we're just going to go ahead and append that to the queue. If it does not, then we're just going to go ahead. No, if it has a right value, we are just going to go ahead and append the right value. If it does not, we don't want to do anything, because we do not need null value. And at the end of this iteration, we want to find the average, which is going to be total divided by the length. This is going to have summed up all of the totals here, so we would have a figure and it will not be 0, and we want to append it to our rest variable. And at the end of all of this loop, we want to return our rest variable. So let's run this, and this works. And this is going to run in a linear time and linear space operation. That's O of n time and O of n space. O of n time because we are running through all of the input given. So our operation is going to run as large as all of the inputs that were given, and no of n space, because we are using an extra data structure, the q data structure, which is also going to contain as much input as we are given. Alright, so let's jump to the JavaScript code quickly, and it's going to be the same thing basically. First, we want to define our res variable, then we also want to define our queue. But with JavaScript, we don't have any inbuilt structure for queue, so we're just going to go ahead and use our normal array. And while our queue is not empty, we want to set our total to 0, want to initialize our total to 0, and we also want to get our length like how we did with the Python code, right? Yeah, and then we want to again only find the average within a certain range, and that certain range is the level that we currently are on, because you saw with the Python code that before we popped off, or after popping off the elements from our our queue data structure, we were appending the children if available. So if we're appending the children if available, that means our queue will continue to grow as large, and we don't want this operation to run indefinitely. So we have to set a range that, okay, you know what, we don't want to work with the children, we want to work with the parents that we started this particular iteration with. So we're going to run the range. Is going to be less than our queue length, and we want to increment. So let's also pop off the value. With JavaScript, we can do that with q.shift, which is going to remove the first element in the queue data structure, and we also want to sum that up. That's going to be total plus or equals none.val, and if there is a left child, we want to push, not append this time, but push to our queue data structure if there is a right child, if our node has a right child, because as we saw that it can also be empty. So if it has, we want to push to our queue data structure, and if it doesn't have, then we don't want to do anything, right? After all of this iteration, we want to push the average to our variable. After every level, we want to push the average, which is going to be the total divided by the queue length, and then we want to return the results. So we should run this, and this should also work fine. Also, I apologize for the thought noise you've been hearing. There is a construction going on near my house. So let's submit this, and this works fine. The time complexity and the space complexity is also going to be the same. I'm going to release a video quickly explaining binary trees, the properties, how to traverse them, how to the basic operations of a binary tree, right? And also the breadth first traversal, the depth first search, and things that you might not be familiar with. So stay tuned, subscribe, like if you enjoyed this video, and I'll see you in my next video. Thank you for watching.